Today I'm going to go over the basic implementation of a tree data structure in C. So a tree data structure is basically one constructed of nodes. So each node will have some data. So in this case, I have an ID as an integer and a string of maximum 10. So 9 characters plus a null terminator. Then it points to the left and right nodes. So over here in main, I have one tree implementation where I have 5 different nodes, and then I'm going to calculate the height of the tree, and I'm going to free it at the end, free the memory, because we're going to be using dynamic memory allocation to create our nodes. So if you want a graphical representation of what our tree looks like, it looks like this. So 5 is the root of the node. This is called the root up here. Then 5 branches down to 4, which branches down to 2 and 1. These are leaves. I don't have enough room to write. I'll write it over here. Leaves. So these are our leaves, and these are our leaves. The leaves don't branch off anymore. They're done. So I'm not going to go over all the different types of trees in this. This is just a basic implementation of a tree. So in the first video, we're going to go over creating a new node, freeing the tree, and calculating its height. Then in the next video, we're going to go over how we can go through and traverse the tree with different orders. So first, let's create our nodes. So of course, we need our node with a new node. We'll call it new node. Do node pointer. We're going to be using malloc. And we're going to malloc the size of a node. So this will dynamically allocate the amount of memory required for one node. Then, of course, we need to check if it failed. And the way we check that is if malloc returned null. If it returned null, that means that maybe we're out of memory. So I'll just print error out of memory. Something like that. And then we'll just return null. We have to return something. So we can return null. Now, if we're outside of this if statement, that means that the dynamic memory allocation worked. So now let's copy over the properties. So we'll go new node ID equals the ID that was given. We use the pointer arrow because this is a node pointer. Then for the string, it's a little bit different. We need to include the string library and then call string copy, our destination being new node string, and our source being the string that we passed in. So we can use string copy for that, and then we'll go and set the left equal to the left, and then we'll do the same for the right, like that. And then we'll return, gotta type return correctly, we'll return our new node. So you don't have to worry about, side note, you don't have to worry about the fact that ID and string, left and right, they both have the same names, because when we specify this means that we're talking about the ID specified in our node structure. But without that, that means that we're specifying our parameter. So that's how we can create a new node. Now let's free the tree. We're not just talking about freeing the memory for one node. We're talking about freeing all the memory associated with the tree. So how can we do that? Well, we could do it recursively because iterating through a tree using iteration is a bit trickier. So we can just use recursion for that. So in recursive algorithms, we need a base case. So our base case is going to be what happens if our root is just null. This is like if we're at the end of the tree. Well, we can return. We don't have to return anything because it's a void function. Then of course we free tree. We call free tree for the left node, and then the right node. And then we free the root itself. So these are our recursive steps. Now you might be wondering, why not free the root first? The reason being is because when we free the root, we lose access to the left and right nodes. So we can't free the left and right. So effectively, going back to here, we free 5, let's say, but then we lose access to 4, 3, 2, 1. So they're still going to be allocated. That means we have a potentially massive memory leak doing that. So to avoid that, we just call free tree for left and right first. And then once we're done freeing all the nodes and stuff, like we once we're done calling those, then we free the root itself. So that's how we can free the tree. Now let's calculate the height. Well, first, for some context, when I say height, I'm referring to the maximum distance between a root node and a leaf node. So what does that look like? So over here, the distance between these two nodes, can I do a curly bracket? That looks okay. It's okay. The distance between these two, if we count 5 and 3, is 2. However, the distance between these is 3. So the height of this tree is 3. So that's with some context. So again, we can use recursion. So our base case is going to be, if it's null, then we return 0. We specify 0 because we're returning an integer. Next, we can get the height of the left subtree and the right subtree. We're getting the height of this area and this area of our tree. So we can say int left, or h left, we'll call it, will be our height function for the left node. Then int h right will be the height of our right node, like that. Then we can do a basic comparison. We can say if h left is greater than or equal to h right, then we'll return h left, because h left is the greater height. And we want the greatest, the maximum height. Then, of course, otherwise we return h right. Oh, we return h left plus 1 and h right plus 1. There we go. And that's how we can properly calculate the height. We first check if it's null, and then we get the heights of the left and right subtrees. Then we compare the two, and we return the greater one. If left's greater, we return left. If right's greater, we return right. There we go. Now, let's return to our tests, and let's see what happens. The height of our tree is indeed 3. Awesome. So that means that our implementation worked. So that's part 1. We've implemented how to create a new node, how to free a tree, and how to calculate its height. In the next video, we'll go over how to properly traverse a tree in different ways. There's in order, pre-order, post-order, and breadth first. More on that on the next video. Thanks for watching. Have a good day.